This problem comes from a Greek mathematician and inventor named Hero of Alexandria. He lived in Egypt, in the city of Alexandria, about over 2,000 years ago, and he was amazing, well-versed in ancient Babylonian mathematics, and he also invented a lot of amazing things during his time. So the question that he asked was, I'm going to phrase it a little differently than he did, just to have some fun with it. So you and your dog are walking on a beach, and you are right here, and your dog is over here somewhere, and it's time to go. He's running around having fun, and you call him, and he's going to run to you, but he wants to take one last dip in the water, or maybe a drink before he leaves. So we'll say this is the water down here. The question is, what is the shortest path the dog can take going from here to the water and then to you? Now, if you know a lot of fancy math, you might think, oh, I can use calculus and figure this out using a min-max problem. But that would be overkill for sure. So why don't you give it a shot and see if you can figure it out, and come back in a little bit and I will show you how to do this problem here. So if you try a few things out, let's use a red marker. Maybe you can imagine the dog goes straight to the water and then he runs to you. That's probably not the best solution. Seems kind of long. It seems like if he hit the water somewhere around here, that would be the best. But where exactly is that point? So there's a fascinating solution to this. What we can do is either, well, let's say we can draw a line straight from ourselves to the water line, and then we'll continue past it here. I'll do this one in blue. And I'm going to continue that line the exact same distance from myself to the water down, so I'm going to mirror it basically. So here I have 2.5 inches to here, so I'm going to go to 5, and I am right I have a mirror image right here of myself through this. It's basically a reflection. We call this symmetry, so this is mirror symmetry. It turns out that if the dog goes directly from here to that point, that would be the shortest distance between here and here, right? I mean, we wouldn't want to go here and then here, that would be too long. A straight line between these 2 points is the shortest distance, right? So let's draw that line. And when I hit the water, I'm just going to make dashes here. This is the straightest line between the dog and the reflection. If this is the shortest path from here to here, and this distance is the same as this distance here, then if I draw this line here to myself, that line is going to be the same as this one, right? You can see that they're both mirror images of each other, so they have to be the same. So that from here to here gives you the shortest point. Isn't that wild? That's crazy. And it turns out, and here on suspected this was true. Hero or Huron, you can say it either way. He suspected that this was actually the path that light takes, and it turns out he was 100% correct. Like, he anticipated it by hundreds of years, over 1,000 years, before we actually knew that that was true. So just a genius guy, and an incredible insight that he had here with this problem. That's true no matter how far you place either one of these. So you could put them at really strange heights, and this will always end up being true. So that blue line is the path. And actually, I bet if you do this experiment, if you could possibly get the dog to do it, that it would probably get close to this. So, do dogs know geometry? The other fascinating thing about this is that the angle on this side of the triangle is exactly the same as this side of the triangle. These two angles are always the same. So how does light know how to do that? You know, if you look at a mirror, the light that's bouncing from the object you're looking at is always going to bounce off in the shortest path possible, and the angles will be the same. How does it do that? How does it know that? Is it math? It's crazy. Anyway, thanks.